Okay.
the presentation.
Thank you so much. So today
Okay.
I will introduce myself first. So
Okay,
my name
please.
is TingTing Han from China. Now I'm a student in Mahidol University. So today I would like to share some of my experience of the forest investigation. So the title is Application of Geospatial Machine Learning Module for Above Ground Biomass Estimation in Mangrove Forest. I can, okay. So for the background is to be able to adapt the rapidly climate change caused by the global warming. It's very important to know how much biomass and how much carbon stock in the forest. However, the traditional method to get the forest biomass is to go into the forest and to do the field work measurement. So it is very waste time and hard labor force and need a lot of financial. So it's not convenient. So we want to break through this method. So today I would like to use the geospatial machine learning module to get the mangrove forest biomass, which is use the drones. Unmanned vehicle. We can call it drones. So we can use the drones flying in the mangrove forest and got the UAV images. From the images, we can generate the 3D module, the cloud point module. And from this module, you can get everything you want of the trace information. So for, so slow. Okay, the scope of study is to develop a geospatial variable window filter module to get the mangrove forest canopy and tree height. Second one is to calculate the above ground biomass of the mangrove forest. And third one is to compare the geospatial module to the ground truth module. So for the study site, we choose the northwest coastal area in the Thailand, which is in the Samut Songkhram province in Klakong's mangrove forest. And this is the method diagram. We have two lines. The first line is we use the UAV method and we control the drones in the mangrove forest, and from the UAV images we can generate the 3D module, and from the module we got the tree's height, we got the tree's canopy size, even we can predict the diameter of breast height, and from this method we can calculate the above ground biomass. And second line is we go to the mangrove forest to do the field work. From the field work we can measurement the tree's height, canopy size by our hands. So from these two methods we can compare the results and to calculate how about the geospatial modules accurate. So first of all, we go to the mangrove forest, and from the picture we can see it's very difficult to do the forest investigation. So we can see we go into the heavy muddy fields. So it's very difficult to working inside, and we need to use our hands to measurement the tree's height, to measurement everything. So it really wastes time and it's really difficult. So then I would like to introduce the UAV flight planning. We just use the drone and we can download the Pix4D software or ArcGIS software into our mobile phone. And we can use the mobile phone to control the drones to fly in the forest. And we just stay outside and push the drone into the forest, and it can take the also image. And the advantage of the drone is that every image has the location. That means you can get the latitude and the longitude of every image. So based on the location, we can generate and computing the 3D module. From the module, we can get everything we want. So next part is generate the module. As I said before, we can use the drone's images to computing the cloud point. For this point is like a 3D module, and we can put it into the ArcGIS. From the ArcGIS, you can get the single tree by single tree. You can if you put into the ArcGIS, you can get the very high accurate because you can measurement every tree's information. However, this time we choose the computer programming because we want to get the results of the whole forest, not calculate the single tree by single tree. So we choose the computer programming. We use the LiDAR to get the results. And this time we calculate two algorithms. The first one is based on the canopy size. So we create a diameter around each point, and we choose the highest point as the tree's height. And the second algorithm is that we choose based on the tree's tops, and we create the we use the tree height to assign the window size to each plot, and for accurate and to acquire the truth segmentation, and based on the every single tree's tops to segmentation the each tree, and to segmentation every canopy size. This method is like the tree is more taller and the canopy size will more bigger. So we use these two algorithms to get the results and compare with the ground field work. So for the results, we can say the tree's height is very interesting because in the field work, our tree height is lower than our geospatial module height. That is because when we're doing the sampling plots, when we go into the forest, it's very difficult to measurement the tree's height with very high accurate, because if you want to measurement the tree height very accurate, you need to have enough distance far from the tree. Then you can use the Leica to aim the tree's height, tree's tops. However, in the real forest, the tree's density is very close, so we don't have enough distance to get the tree's height. That's why the our field work tree height is lower. So I think in this part, the module's height is more accurate than the ground truth data. Yeah. So for this way, we calculate the biomass and the carbon stock by using the allometric equation. So we can see actually the results have the big distance. Our regression is only around 0.3. That is because the field work limitation. Yeah, I think if we can improve the field work accurate, the results will become better a lot. Yeah, because the geospatial module is more reliable actually. So for the conclusion is that when we're doing the forest investigation, we can use the drones to help us to with more efficiency, because as I said before, in the field work, not only very difficult to work, also the result is not very satisfied because it has a big limitation. So in the future, so we would like to share everyone to use drones to do more and more work, because it's really convenient and it can generate the module. From the module, you can calculate a lot of things. Yeah, and yeah, that's all. Thank you so much.
Okay, Ms. TingTing, thank you for your great presentation. Yeah, maybe I would like to share to the floor. Is there any question or comment?
Yeah, please.
Please, anyone? We still have many time in here, about 12 minutes. Okay, if no, maybe I would like asking first. Is there any specification of the drone that you use? There is maybe I'm missing, or the specification, the drone that you use, the UAV that you use for this research. Oh, you bring your drone.
Oh, I bring my drone. It's
your drone is quadcopter, quadcopter type.
It's a DJI Phantom 4 Pro.
Yeah, DJI, yeah. Okay, so this only can flying for about how long?
Yeah.
Half an hour?
Not half an hour. Only we fly around 3 times, and every time only 5 minutes. So total
5 minutes.
Yeah, total 15 minutes. That's why I want to introduce this method, because it's really convenient. Only 5 minutes you can finish the data collection.
Okay.
So, but for us goes into the forest, every sampling plot we need cost around 1 hour. 10 meters multiplied 10 meters, we need cost 1 hour. So that's really difficult.
So the highest that can achieve, how long, how many meters?
150 meters to flying.
Oh, only 150.
Yeah, because 150 is enough enough resolution, and the choice you can, and the resolution is around 3 centimeters, so it's very high resolution. So we choose 150.
Okay. So the main object in here is to measure the height of the trees, right?
Yeah, to measure the height of the tree, and to get the canopy size.
The canopy size.
Yeah, from the computer programming, we can get the tree's height and the canopy size, because it can help us to segmentation. So if you wanna, because we use the computer programming, is very convenient. If you wanna improve the higher accurate, you can use ArcGIS and measurement by your hands. And in the ArcGIS is more accurate, but you need to use long time.
Okay. So when we already know the tree's height and also the canopy diameter, what the information that we can get, what that's imply?
Yeah, we can use the allometric equation to calculate the biomass, because when you want to calculate the biomass, you need to have the tree height and the canopy size, and based on these two parameter, you can calculate biomass, and the carbon stock is normally is a half biomass of the forest. Yeah, so you can get the carbon stock of this forest. So in the future, you will calculate the carbon stock very easily.
Oh, that's smart. Yeah, I think you should continue your research. It's a good idea. Okay, maybe still, is there any question from the floor, please? Yeah, this is very interesting research.
Yeah, it's very
in my lab, in our institute also, we also develop the drone, but for the physical distancing for the COVID-19, like that one. The application, yeah. So we also develop the algorithm in order to determine this is the safety for the physical distancing for people or not, or like that one, and then the information will inform to the COVID-19 what we call guard. But your approach for the application for the agriculture, for the forestry, is very smart, I think.
Yeah, agriculture is also yeah, because the model can do a lot of things. For example, the last presenter, he researched on the mammal mine. He can also use drones to calculate the volume of the mine. Yeah, it can use in a lot of fields.
Yeah, moreover, the issue of the CO2, the greenhouse gas, is also very important. Yeah, so with this approaching, I think, it's very smart move. Okay, great. TingTing. Is there any question from the floor? No? So if no, maybe we can move to other presenter. Okay, yeah. Anyway, thank you, TingTing, for your great presentation. Okay,
Thank you so
please
much.
give a big applause for TingTing. Thank
Thank you so
you.
much. Okay, I will disappear. Bye bye.
Bye bye.